So open up, actually let's first talk about the website. So the website, as you can see, it's got this little, this little thing. We can go like that.
Oh, that's what you can do?
It's enter3dprog.herokuapp.com. Basically, whenever you go here, if you haven't already done this, you click on sign up. It'll take you to sign up. You can do, put all your stuff in, save changes. It'll bring you to your profile, which I already have. So let me do this. I'll sign in. And it'll bring you to your profile. Now, it'll list your pages, and I'm going to do this a little bit better in the next week or maybe even tonight. Where it'll list for each week what you did for the work. And so the big thing about this, or the cool thing about this, is once you actually get some stuff up here, you can click edit. You can go in here and you can edit stuff like so.
So, hang on,
and you can change things just by clicking the preview. Go ahead, Mike.
Yeah, so before all this,
Yep.
I've signed up, and then
and you're on your profile.
So to add a page is to add an assignment, right?
Yeah, basically to add a page is to add an assignment. So I'll go through that really quickly. Here's my new page. And then I'll write hello. And as hopefully you know, HTML is just text. So whenever I save changes, it'll show me my page, and my page just says hello. If I want to say hello, Ryan, and hit preview page, it'll just throw that code in there and redo it. So you can actually, like, once you upload something, you can just preview the page and preview changes from this website. And pretty soon we're going to put a modal so that it pops up and it's like a little editing window. And then you preview, me and Sam. Sam's doing the CSS and stuff for it. So yeah, and then you could just save changes and it'll save your changes. And then you can go to your profile, and there you see, I need to change this. So it accidentally made 2 copies of my page. I'm going to change that. But you can just quickly delete it. Any pages that you've already used or whatever, and that seems to be a problem as well, but I'll fix these things out. Also, let me know anytime that there are problems on the page so that I can fix them as soon as possible. Now there's this other thing called forum where if I were logged in, let's do that again, you can add a topic. So down here next to add page, you can add a topic, and you can ask questions like, has anyone done the homework? And I'm having trouble with so and so. And then you can save the topic. Should bring you there. And then basically you can reply to the topic. Yes, I have. It was pretty easy. So this is basically our replacement for Google Groups, because I hate Google Groups. Does that make sense? So does that make sense? So now you can like reply to it and whatnot. So this is where I'd like most of the discussion to happen, if possible, just so that we can. And I'll also make it so that these like shrink, so that we don't have like you have to search, and they're also sorted by time, so the latest ones will be done. And I want to make sure that people get like things on their profile if they haven't been logged in since a new topic has been brought up or whatever, just to notify people. So that's the page. I want most everything to be done on the page. I'm probably going to write emails every once in a while to let you know logistics about stuff. As it comes up, or to talk about other stuff, but most everything, all conversation should happen on this page. That's what it's there for. Now, in the About section is where you'll find all of the assignments. So we'll also make this a little bit better, just so that you can see that this is an assignment rather than a lesson. But as you can see, under each lesson, there's going to be an assignment that'll happen like right after class, hopefully. And there's also 3 huge things on this website. First, there's the link to the course on Udacity, which will just bring you straight to the thing. Hopefully you guys have signed up for the course. If you haven't, you can do that later. And second is the actual book, WebGL up and running. You can actually download the PDF. It's a link directly to it. And third is the GitHub for all of the examples in the book. So this is like written out all of the examples in the book, chapter by chapter. So it's good. You can clone it if you know how to use GitHub. If you don't, you can just download it. Any of those things can work. It's pretty easy, and whenever you go into the chapter 1 or chapter 2 or chapter 3 and so on, it'll show you the chapters, just the HTML, and it'll be like all of the code. So here brings us to something that is a little bit harder. Go ahead.
So you say, like, the assignment, do the introduction example to WebGL. Could you, for the future, do example 1? You know what I mean?
Yes, but it's not going to be that cut and dry. The first chapter is that cut and dry because I just want you to get your feet wet, but most of the next things will be like, do the chapter 2 reading and also do, this type of thing, like make this thing.
Okay. But this
So-
is 1-1.
But this is 1-1, correct. And you'll see as you read the chapter, you can kick back and forth. So this brings us to how the format of your code for when submitting to the site. So basically, there's a couple of things that you need to be wary of. The way that I created the site makes it so that you only have to include your script with script tags, so the script tag around your JavaScript, and the canvas. You don't need to worry about any other HTML. So whenever you're looking at examples or doing these types of things, all I want, like this isn't a class about HTML or about CSS, so just put the script into the thing and put a canvas. We will always be working on a canvas. That will be 100% what we do. So just make sure that you're always working in, like you have 2 things. You have your script that's in between 2 script tags, and you have your canvas. And you can have other script tags, and we can talk about like adding JavaScript to the library and how to do that and all that type of stuff as we go further. But for right now, you don't need like this meta or this HTML or this head or the body. Like you are basically putting all of your code inside of my body that I created for you, which is hilarious. but yeah, so think about it like that.
So so you're saying on the pages that we create, so when I go to my profile to add a page, I'll have to add in HTML.
Is the script and a canvas.
But between HTML tags and a head tag?
No, you don't need anything
Just
other than
straight
2 script tags
away.
and 2 canvas tags. That's it.
So you
And in
started-
between the script, you'll put JavaScript
Yeah.
and nothing between the canvas. And you'll leave, you
Yeah.
will never put any other
So,
type
okay,
of tag.
So that's it.
So yeah, no
script,
HTML, no body, no head, no title, no meta, nothing.
Just put a canvas.
Just canvas and script. Yeah, because that's the way that I got it to run.
What parameters do we put for the parameters in canvas?
So you can actually you can use jQuery, so you don't have to include jQuery unless you're working on your home computer. I have jQuery loaded in, so you don't have to include it whenever you're I'll show you kind of how I work, and then I'll show you how to turn that into putting it on my page. But basically, you can use jQuery to grab canvas and grab Windows size and give canvas the Windows size and all that type of stuff. So you actually don't need any of these parameters really, other than an ID, so that you can grab it. So get element by ID or any type of jQuery parentheses quotations will grab that hash ID. So I'll go over it once we get into the actual coding. The other huge thing is no single quotes. No single quotes. So don't use single quotes. Even though you can use single quotes in JavaScript, do not use single quotes because you'll fuck up the whole thing. Because it's kind of complicated to talk about, but basically this is all being loaded into us. Actually, I can just show it to you. Pages. Let's see this. So if you, oh wait, actually from my profile, if I go to edit, the way that you're editing this stuff is like a little bit of HTML5 magic. So whenever you can, so this is the console, but basically what I'm doing is grabbing this stuff and then throwing it into this source doc. So this, like, literally all of your code is going in between these double parentheses. Yeah, this is how I'm making this whole thing. So that's why it's easier for me to like upload this stuff to the page really fast, is because I'm just grabbing all the text and reloading the iframe, basically. So do not use any single quotes or you'll fuck everything up. If that makes sense. Okay. I'm gonna send this whole thing out in an email. But all right, so yeah. So I think that's pretty much it on the thing. Feel free to email me if you have any other questions about this stuff. And cool. So using Sublime. Sublime is great. It can pretty much edit in any language that exists, and it's relatively fast and all sorts of stuff. So the first thing you want to do is you want to save your document, or open up a new document and then save it. I'm going to save all of my stuff inside of my homework, and I'll just do week 1 for this, and I'll name it, my first webgl.html. Which I'm going to take out these spaces. Cool. So it'll save it, and then down here you can see at the bottom right, you can see that it's an HTML page. So what's great about it is that it'll have a lot of autocomplete for HTML. And even when you're like editing in here, you don't need an HTML head or any of that type of shit. Like it's mainly just for like, if you're I don't know, some big corporation and you want to make sure that your website can be seen everywhere. That you need. So let's just do, so you can see that it auto-completes script. And then I have my script. And now anything between these two, like script, will be JavaScript. So I could say var hello equals string hello. And then I can say alert hello. Now the cool thing about Sublime Text is that you can easily just check to see what's going on in the browser. So I can just say open in browser, right click, and then open in browser. And then it shows. And so it ran my script and it says JavaScript hello. I could say, I could do a lot of things. What could I do? I could quickly make a div tag. Now again, this isn't something that you have to do, but just so that you can kind of understand what's going on. You can make a div tag. I can give that div tag an ID, so you can imagine that this is kind of like its variable name in essence. So that ID can be just like my div, right? And I could say var div equals document, which is the document that I'm on. That's the object. Get element by ID, right? So it's like literally grabbing whatever thing there is in the document and then putting it in that variable. So I'm going to put my div, and it auto-completes it. Then you can say, I believe it's like div.text hello, I think. I'm not totally sure that this is going to work, but maybe it will. And then you don't have to, you don't have to go back in here and open in browser again because it's already open. So you just refresh your page. That did not work. Let's see why it didn't work. Inspect element.
Is there a way to enable JavaScript
It should autocomplete if you are on an HTML. Go down to the right, the bottom right. It says HTML. Oh, no. Not like C++. Not like Xcode. Yeah. So what was it? Maybe it's yeah. .html maybe is. Let's see. Cannot call method HTML of null. Yep. HTML development. There's no method HTML. Oh. So what's happening here is that it's loading the page. It's loading the script faster than the div is getting there. So sorry about that. So it's actually like not catching the div. So I had to put the script afterwards so that would be in the. It has no method. Okay, well, let's see. I don't know much DOM stuff, so you'll have to forgive me. But get element. Yeah, you'll have to. You'll have to forgive me.
You have to forgive me. Where's that from?
You want what? Yeah. So no, you don't need HTML. You just need. Let me just see what the actual div dot h dot. Let's see. Dot. Oh, really?
Yeah.
Like it was full? Ah, buddy.
How could you do that twice?
Yeah.
It's not allowed to have water.
Yeah. Yeah. Shoot. Hold on. Text, content. Oops. Yes, I have a lot of stuff in there.
You have like.
Alright, let's see if this works. Sorry, guys. Text content. Okay, well, anyway, this isn't about HTML, so I don't care about the DOM stuff. Basically, what you'll want to do, we'll go through it as we go through the chapter and like the homework and whatnot. Oh, I see. That's what you were asking.
Hey, open it and take stuff out.
Yes. Huh. I don't know. That's really weird. I mean, you can just do this. We're going to fold and open it up. Oh, whoops. Huh. Is it not saved as HTML? Oh, it might not be saved. Yeah, it's not saved as HTML. So let's do this. Just HTML.
Oh yeah. First half of what?
All right.
The first half of what?
Okay, so let's go through the chapter. So I'm going to go through the chapter.
What happened to what you were doing?
I mean, it's so not what we're doing, so I'm not going to talk about it anymore because I don't remember what the commands are. I could look them up, but
No, I mean if it's not what we're doing.
yeah, it's not what we're doing. So this is how you will set up every single thing. Script. Okay? Above script, you will put canvas. And that is literally all you have to do in HTML. So I'll go over a couple of things in the book, just quickly, like in the first part of the chapter. Most of this is self-explanatory. Okay, so 3D coordinate systems we're going to start to talk about tomorrow, so I'll leave that for tomorrow. But this is like the complicated stuff of graphics programming. So like you will get frustrated, you will not understand it at first, most likely. Be okay with that, and then keep trying, okay? Because it took me a very long time to figure a lot of this stuff out, and I'm going to try to help as absolutely much as possible, but it is just the most complicated part of this whole thing, and in my opinion, the most important thing, because movement and, you know, being able to see your object is by far is more important than what your object looks like, or more basic and more fundamental. Materials, textures, and lights we'll go over. Those are fun. Those are like tweaking, and then you'll get a sense of what's going on with them. And that's where, you know, graphics start to come alive. Transforms and matrices, that's like specifically the really, really tough stuff. So we'll talk about that at length. And that all goes into camera's perspective, viewports. And shaders are hard, but you don't ever have to really do that much in them, and there are a million online, so as long as you start to understand what shaders are, you can just go and steal them from everywhere and get the look that you're going for.
The more that you play with them from doing that, you understand how to work with them.
Exactly.
It starts to be.
Yeah, totally. It gets super fun. So this is the actual GL is the hardest part, and I'm kind of glad that they go through in the first week, like basically all of this GL, and it's like, it's so scary, I don't want to do this anymore. What we're going to do over the next 10 pages, and what we're going to write out, you know, a lot of code, in the second chapter will be done in 13 lines in Three.js, and a quick, like, you know, paragraph, basically. So, though this is like very hard, and don't worry if you don't understand it all, I'm going to try to give you as much, you know, information as I possibly can. But, you know, don't worry. It takes some time to get to this level. But it's just showing you like everything that's going on under the surface. So, what we're going to be doing for most things is actually written out in these 8 statements. Create a canvas element, which we did right up here. Obtain a drawing context for the canvas. So we'll actually like make a variable, grab that document by element ID, and then we'll get a context, we'll pass it in, and then it'll pass us back like, okay, here's GL for you, and then we can use GL to call a bunch of different things. The next thing, we initialize a viewport. So that's you can think of that as like a window into the 3D world. So however big or however small is basically like if I were making a world that's say like 40 miles wide, like a camera, 40 miles wide and 40 miles high and 40 miles back, I could put that whole thing, if I made the viewport just 0, you know, the bottom left corner at 0, 0 and 100, 100, it would just become 100, 100. Like it would just become 100 pixels on the screen. So that's the way to think about the viewport. Is like basically, so like no matter how big my world is, the viewport is my window into it. So what settings I give it are what I will see, like the length on the screen of what I will see. So it's like pixel area. So if I said like the bottom left corner was 0, 0, like the origin, and the top right corner was 100, 100, then my world, no matter how big it is only 100 pixels by 100 pixels. Does that make sense?
So as you're writing your program, you might be writing everything in a space that's 400 miles by 400 miles or whatever. But when you change your viewport, shrink your viewport, it'll scale your world down to what your viewport is, because that's the last matrix.
Exactly, that's the last transform that will happen. So, like, you can have an enormous world with a billion objects that all fit into a banner ad. and that's all done with GL viewport.
And that's stuff that you determine, like,
For every.
You'll always declare a viewport.
Yeah, yeah.
and
And
you can't change. It doesn't transform. Like
you can change it at any time.
No, I mean like it doesn't change as the thing's already made.
No,
Like,
you can
once
change
you
it
set
anytime
it's
you
done.
want it. You can change it anytime you want to change it. So create one or more buffers containing the data to be rendered. So this is like geometry and objects and stuff like that. So it needs data to show. Create one or more matrices to define the transformation from vertex buffers to screen space. So basically, it like distorts and grows or shrinks or moves or rotates or does anything into the camera view. So we'll talk a lot about this because this is pretty much the hardest thing about this stuff is this right here. So then create one or more shaders to implement the drawing algorithm. This can be hard or it can be very, very easily. Initialize the shaders with parameters. This is like a rinse and repeat thing that always happens. And then draw. Like there is just, you enter in this thing, it takes in a string and it initializes the shaders for you. Like, you will never need to worry about like.
So you set them up in number 6 and then you draw them.
Yeah, so setting them up in number 6 is the hard part. 7 like is basically OpenGL is like, here you go, just put it into here and it will take everything. So let's talk about the canvas in the drawing context. So let's start coding. So from the talk that we had, you probably remember how to create functions. So we're going to create functions. Great thing about Sublime is that if you write fun, it'll autocomplete. You can just hit return and it'll pop up function with like function name that you can change, an argument, and you can tab between them. You can tab between all of it. So let's. I want to stick directly to the book, so just stick directly to the book. WebGL, init WebGL. So basically, it's literally initialize WebGL, and it's going to take a canvas as a parameter, but we're not calling this function yet, so don't worry about it. So we'll create a variable, var GL, and then you don't have to worry too much about what this thing is right now. Again, a lot of this stuff is going to be taken care of in by what is the Three.js. But try and catch is basically saying like, literally, it's like it's going to try what's inside of this brace, and if it throws an error or it says like I don't have like a WebGL experimental context, then it'll catch that error and it'll tell, and you can do something with that error. You can tell it to do something, or you can initialize some other type of thing, other type of context. We're not going to be too worried about that because we're only going to be using Chrome, and we will not have any problem. But just for the sake of writing everything, let's just go ahead and do it.
This is just for when, because I was reading all this, this is just for when you have like different browsers. Right?
Yes, exactly. And we will never have another browser, and that's just complicates things and makes everybody's life miserable. So
this is kind of just like your basic setup, though. So
yeah, this is just
this is a file that you can always replace.
exactly. You'll never need to do it again, basically. So WebGL context. I don't even care to put out the string. And then alert just in case. And throw error. So again, this is more, kind of like not low, super low, but lower level stuff that you don't really need to know right now. So then we're going to return GL. So you can imagine that like this init WebGL function is going to be on the right-hand side of an equal sign. Does that make sense? like you could see maybe it's like var gl equals init webgl canvas, and we've already got a canvas thing, and so we're basically going to return it to GL, and that'll create the GL context. Okay. So now, yeah, this is pretty easy as well. Function, another function. Init viewport, and we'll take GL, and we'll take the canvas. And as you get crazier with this stuff, you can like stop passing canvas, because then you can just have jQuery elements that already have all of this stuff, so you can just get it from anywhere inside the page, which I'll go over as they come about, but you can really like do a ton of this stuff without passing all these variables. So this is the first time you see a GL call, and the GL call is GL viewport. So you could think about it as giving it two, like basically an origin point, and then width and height. So canvas dot height. So you can think about it like if you started here, like you're giving it a point somewhere in space, and then you're saying now go to here and go to here, and that'll be your top. Right.
Coordinate space in JavaScript, GL, actually WebGL,
is opposite again.
Opposite. Okay,
Yeah.
so
So
more like regular Cartesian, not inverted
no,
Cartesian.
it's opposite of it's how it is in Cinder.
Oh, okay.
It's how it is in Cinder. So it's flipped.
Bottom left is 0, 0.
Yeah. So like a lot of times you think of like film or kind of not television, but movies in your computer from going from the top left down to the bottom right. GL and other people, because of mathematics, flip that. So the 0, 0 is at the bottom left and upper right. You won't necessarily need to know that in this course, because I think most of the examples are done to where you don't actually even need to know that stuff. But if as it comes up, I'll kind of talk about it.
Is it because of what they were explaining in the first chapter about how you see things?
No, it's specifically because like if you could imagine like there's like a coordinate system. The origin is right here, and this is positive. Whereas we think about it as going from here down as positive. It's like in processing, you think plus plus is going down basically.
I have another question.
Yeah.
So you initialize the canvas with those flags, but then when you refer to the parameter.
I haven't initialized the canvas yet.
So you just got the context for the canvas?
Yeah, but I haven't actually gotten the canvas. So that's like, I'm assuming right now that what I will be passing into this function will be the canvas, but I actually haven't gotten, there's no variable in here right now that is the actual canvas.
So it's writing the functions that are going to initialize?
Yeah, that's going to initialize everything.
And then setting up the viewport.
But the canvas tags, what are they saying? They're just saying do all of this.
So canvas, you can think about this like it's yeah. We'll talk about that later.
In the functions, but like in the tags.
What tags?
At the top.
Oh, yeah. This is literally just so that your browser knows to like create a canvas. And then later we're going to say like document.getElementById. And then we'll give it the ID of the canvas, and then it will grab that thing, and that thing has like a bunch of, exactly.
So we're not actually doing anything yet.
Yeah, we're not actually doing anything. We're just setting everything up. Exactly. Exactly. So we've now created the viewport, and again, this is this is the low level. So this is we're doing this right now so that you get an idea of what's going on behind it, but you won't ever have to do this much setup again, most likely, unless you want to. All right, so buffers, array buffers, typed arrays, all of this stuff is like the bread and butter of GL. Basically, you've got to get data from your CPU memory into the GPU memory, and the only way is on a ship that is basically like sailing towards the GPU. And the way to sail stuff to that ship is to ask GL to create buffers inside of itself and then pass all of your data to it at once. Or not at once, but as fast as possible. Yeah, you have to create a place for things. So let's make another function. Create square. GL, we're going to pass it GL because that's the thing that we care about most in this in this function. And you can imagine that we've already initialized GL. But this is just, but don't get me wrong when I say this GL is just an empty vessel that I've decided to call GL because that will be what will take its place later. So we'll create a variable called the vertex buffer. Now vertices, I'm sure you guys know, mostly are points in coordinate space. So we're creating a vertex buffer, and then we're giving it equals gl dot create buffer. So we are actually calling a GL function. We're asking GL to create a buffer and then pass back the ID, which is basically just like an integer. Like it'll query the GPU and it'll send back like, hey, ID number 1 is totally awesome, go for it. And so you use that to send stuff. So now you're going to do bind buffer. So you're telling GL like, hey, can you make sure that everything that I do for the next little while is on this specific buffer?
On the ship?
On this specific ship? Yeah, exactly. And this array buffer, don't worry too much about it. There's just different things that you can send or create buffers of. Now these are the verts, and we'll make an array of basically of vertices, of floating point vertices. You can just fill these in. This is the only time that I want anyone doing this, but I don't want to write all these numbers out. But again, just write all the numbers out if you haven't already, because it'll get you used to it. But I've already done this.
So what you're doing there is, what are all those numbers?
Okay, so you can imagine it like this. Here's 1. Here's 1. Here's -1. Here's -1. So what I'm basically saying here is my first vertex is 5.5.5. So that would be right here.
Right.
And my next vertex is -0.5.5, so that would be right here. And my next vertex is 0.5 -0.5, which is right here, or maybe right here. But basically, these 4 vertices, when they're connected later, form a square. So
these are the vertices of a certain shape you're thinking of drawing.
Exactly.
It's not like of a canvas or of a drawing space. It's like
Exactly. This is like what I want to draw. So you know, 0.5, 0.5, -0.5, 0.5. These things specifically matter to what I am actually going to be drawing. So then now you've created your data. Now you've got to buffer your data. So you actually send. Now this is basically take this information and sail it to the graphics card. Buffer. New. Okay, so this is a little bit interesting. So you know how we talked about how this stuff isn't typed, JavaScript isn't typed? Well, GL is C, and it's like, fuck you and your non-type. Like I need to know I need this to be exactly what I expect it to be. So by saying new float32 array, I'm basically saying take what the array that I made in JavaScript, which is kind of piddly, and make it for sure a 32-bit float array. So you're basically creating like a specific type for that GL that like GL only understands. And now you're saying, now you're creating, okay, so this is an object. Now you're creating an object. So var square equals, and these little, curly braces, these tell you that this is an object. So you're saying my buffer is the vertex buffer. So you're basically giving your square data. So vertex buffer, and then vert size is going to be 3. And number of verts is going to be 4. And primitive type, like the thing that we want to draw to the screen, is going to be GL triangle strip. Now we'll get into this stuff whenever we need to, but there's just like a bunch of different ways that you can draw to the screen. And then,
Stuff that we looked at in the video class.
yeah.
Like the order in which the
Exactly. So, and at the end, you're going to return your square. So basically, all this stuff creates your square. And you can imagine, again, that later in the code, we're going to have something that says var square equals create square. And then you're going to pass it RGL thing. And so then that square will have this information, all of this buffer and vertex data and, the number of all that stuff.
How are you passing the verts?
What do you mean?
How is that being passed to the code?
I'm just literally creating a name for it out of thin air. Like this could be int vert size if that.
No, I mean the numbers.
Oh, these verts?
Yeah.
Right here? Oh, I created them right here.
Oh, because you made it.
Yeah, and then so I have like the array right here, and then I just pass that to the typed float array, basically.
Okay. Can I just run through this?
Yeah,
Make
totally.
sure I understand?
Yeah.
So, to create a piece of primitive for webgl, you have to first create a buffer, which you're going to call to GL and say, hey, make a buffer and give me back which one's available.
Yeah, the handle,
And
basically.
the handle. Okay, great. So I'll get this one. It doesn't matter what it is. GL. Let's take care of that. So
Yeah.
I'll get that, and then I'll bind that buffer. Or no, and then I'll bind. Okay, I'll call the GL and say, okay, bind me an array because with this handle because I'm going to need an array of all these coordinates.
Right.
And then I'm going to create an array of those coordinates.
Yep. And then
I'm going to pack them up and send them to that data or send them to that buffer. So
Right.
Buffer that data, and they need to get typed so GL understands them. So we're going to make a new float array.
Right.
Float 32 array to hold in, and it's going to be of type static job. Because we won't be dynamic between these things.
Right.
And then lastly, we need to, for JavaScript, we need to make an object. An object needs to have the buffer.
Yeah, which is the handle.
The handle, right?
Yeah.
It's just the handle.
Yeah.
So the handle, the size of the vertex, each vertex, the number of vertexes, and then how we want to draw the
Primitive, yeah. And then you return
and then
that.
you return it. So
And you'll grab
every
that.
Time every time I call the create square function,
It'll create
I'll
another.
square.
Yeah. You'll just get another square. Yeah. Cool. So, that is a square. Now we get into matrices. Now I'm not going to talk too much about this, but let's just go through it. Again, this is hard, so I'm going to wait until we actually get a little further into this before we talk about it. But basically, we're going to make another initialize, and we don't actually need to pass anything in because it's just going to initialize them. You could imagine that maybe there are, specifically there are variables called model view matrix and projection matrix somewhere else. So, and you will also rarely, if ever, write matrices like this. So I'll do a really quick thing, like that could blow your mind, it could not. But basically, what's happening here, just go ahead and start writing it, is, what? Yeah. So what's happening here is this is not going to change x, right? So 1 0 1 0, or sorry, 1 0 0 0. Then this is not going to change y, right? So that second row is not going to change y. This third row is not going to change z, except, hold on for it, it's going to translate, now we're on the translate line, z back 3.333 units, basically. And units are whatever we define them as, and we'll talk about that. And that's kind of the hard part about a lot of this stuff. So does that make sense? Like, I'm not changing x, I'm not changing y, I'm not changing z in any discernible way, except when I get down here, this is the translate. So I'm actually translating 3 spaces back in space. So again, maybe it blew your mind, maybe it didn't, but we'll get into this and it'll become more clear as to what's going on. Now, projection matrix is actually extraordinarily hard because it's dealing with a lot of things, but matrices deal in exactly that rationale, where they have x, y, and z. But we'll, again, don't worry, we will deal with it. It is hard. Don't fret. Just enter in the numbers as they appear. 4, 1, 4, 2, 1, 0, 0, 0. And let's see. 0, 2.4, 1, 4, 2, 1.
Yeah.
2. Yeah. Well, so there's a lot of mathematical equations that make this number really, really easy, but I just don't want to go into them right now. Or not like not easy in the sense that you could just easily do this, you know, by hand.
This is a number that
But this is a number that's easily figured out once you know a little bit about it. So cool, that's all we're doing. So basically, we create the projection view matrix and the model view matrix, and we're done. Shader, pretty standard. So the only unfortunate thing about shaders in WebGL is that you have to surround them with a string, basically. They're basically one long string. And that's how the compiler looks at them. So you don't do this, but I'm going to do this. I'm just going to copy and paste because while you're actually writing these things down, I want to kind of go over what's happening here.
So right now we're just
sorry. Yeah. Sorry, here. I mean, all of this is in the book, unless you're not looking at the book, and then I will move my stuff down. All right, so there's a vertex shader. Well, when did we make vertices? Just a little bit ago.
Is everyone caught up with something?
You know, it's kind of
Is this how we
infuriating.
have to do it all the time?
Yeah. But you can write it and
And
then
put it in.
put it in. Yeah. 1, 2, 3, 4, 5, 6, 7.
That's not inside the function.
4, 5, 6. Yeah, this is, I'm making a variable string, basically. I'm making one string. Okay, so let's talk about this. I'm going to go over this a lot throughout the semester because I really love shaders and I think they're awesome. And there's a lot to them, so it is very hard, and don't worry too much about them right this very second because you'll get it. So this first thing is a vec3. It's basically a vector, x, y, and z, and it's vertex position. Well, when did we see vertex? We saw it up here. Well, so this vertex shader is going to, okay, let me back up. So what shaders are basically little programs that run on the GPU, and they process different types of data. So you can think of a vertex shader as processing the vertices that you sent to the graphics card, whereas a fragment shader is processing fragments or what will become most likely pixels on the screen. So while that is a very kind of, easy or not great way to think about them, it's kind of the actual truth of the matter. So let me really quickly finish this. Just quickly finish putting these in. Here we go. Grab this. No, but you will. Hold on. Give me one quick sec. All right. Also, if you just copy it out of the book, you will get it wrong because they missed one. Whatchamacallit, not parentheses, but quotation. All right, so quickly, I'm going to go through this, or not quickly, but basically, you can think about it as you can go back over this. So an attribute is an actual single entity that is coming into this vertex shader that makes it unique from everything else. A uniform is something that goes across every single shader, and it's something like a matrix that every single shader shares one value. So, like, for instance, for each of my vertices that I've created up here, I don't want a different model view matrix. I want the exact same one because this is one model, right? Does that make sense? So I will send the uniform. I will send one version of model view matrix and one version of projection matrix for this vertex shader because I want all of the vertices across all of the actual programs that execute to share this exact same number. Does that make sense?
This little shader program, both this vertex and fragment is going to operate on every single vertex and pixel in your program, and it's going to do the same to every single one. And the only difference is between the attributes and the uniforms. And the uniform is going to be a variable that goes the same for every single one, and the attributes will be different.
Yeah. So like up here you can see these verts and you can now think of them as X, Y, and Z. So whenever I buffer this data and say whenever I draw, it's going to fall right here. So each one of these, so there's 4 here, each one of these will take over this vertex pause variable name, and it will use that to actually like create this position.
Since it's a vec3, it's going to take the first 3 pieces of data and put them in
Exactly.
that attribute.
Yeah.
And when it gets to the next vertex,
It'll put the next 3. Yeah, it'll put the next 3 in, and it'll buffer it exactly like that. Yeah, because little do you know, GL doesn't know what a vec3 is.
Yeah. Right.
So
It just
it
knows-
literally just has a long string of data, and then GLSL knows what a vec3 is. So
I have
so
no idea what's going
that's fine. Don't worry. This
on.
is
Like, at
not.
all.
We're not even actually going to be talking about shaders necessarily until the last class, basically, or the second to last class. So
So why are you freaking out?
don't freak out. It's just another program. It's just another program that like your GPU is going to run. So it's basically we're writing this program to give GL stuff. Well, then we're writing another program that we're going to give GL that GL is then going to perform by itself somewhere else. But don't worry about like the actual like. I just want you to see like what is actually going on.
Is this kind of chapter? Is this kind of like building a conceptual framework?
Exactly.
And showing us some code.
Exactly.
But not worrying about specifics.
Exactly. So don't worry. Just let it wash over you that like, oh, there's we're going to be meta programming kind of.
I don't know what that means.
Like we're going to be creating programs that like send programs. Like,
Oh yeah, that's right. Okay. Oh yeah, of course. This is this program string.
yeah. So but it's cool. It's fun. It's neat. Like I know that it's crazy and conceptual right now, but you will get it. Trust me. So yeah, you make this quickly, and this is pretty much what your shaders are going to look like for most of the class.
But I don't have to worry about like what's attribute.
You will at some point, but right this very second, just understand that they're basically two computer programs. Don't disregard attribute uniform. Just look at vec3. You've seen OF vec2f or OF, You've seen what you may or may not have seen a matrice, but these are just like
That's what you just
types.
defined it for,
Yeah, these are just types. And then this is like the name of the actual, this is the actual name of the variable that you're going to use in this meta program. And then you're just literally multiplying these three things together. And that gives you a position. And that's it. That's all you're doing. And then down here, return the pixel color, always output white. This will always output white. So this is basically a color. And you can think of it as red, green, blue, and alpha. And it's stored in a vec4 only because that's just a simple data structure. And you're just giving this, piece a fragment.
All of these programs are being rendered in the CPU and then sent to the GPU?
They're basically strings on the CPU, and then you send these strings to the GPU, and it compiles on the GPU and does all that stuff. So, yeah. So just a little look into it. I swear to God, it took me forever to even get close to understanding it. But now that I do, I promise you, I will help you understand it. I swear it's not the end of the world. So be very, very excited. No, it's never going to be the end of the world. All right, so let's do this last one. Function, draw, GL, OBJ, right? So this is by far the most calls that we will be making to GL, in the chapter. So right now we're going to do GL, clear color. So you can imagine we're going to actually clear a buffer. I don't want to talk about that right now. Just basically I'm giving GL a color that I want it to clear the screen every single time.
Like you have to draw the background process.
Exactly. Background in processing is exactly clear color. And this next one, GL clear, which says GL color buffer bit. So you're telling it like clear that GL color buffer with the color that I just gave you. Cool? Then you're saying again, you remember GL bind buffer. You're saying I want everything that happens after this call to go directly from this buffer. So here it says obj, but above we created a square. So you could imagine that we would pass in the square for the second parameter to this function, and it would then take on the name of obj. Then you're going to say, hey, GL, use that program that I gave you just a little bit ago, you know, the vertex shader and this fragment shader. Go ahead and use that shader program that I created, because I don't want to make another one. You could imagine that that probably happens in the compile function, or the init shader function, which I'll get to in just, yeah, we haven't written that. But so then, and again, don't worry, because this is fine. This is just showing you like how much is going into making your life the easiest life that lives. So shader vertex position attribute is basically just what it says. We're sending that attribute, remember, from the shader. We're going to send it. You could imagine that this is another handle that GL has done, and we're like binding this handle to obj.vertSize. Is camel case? VertSize, I did not. I should do that. VertSize. So basically, VertSize is saying there are 3 floats in each one of these. And then you're saying GL float, because remember we made that float 32 array, which is what GL likes. And you're saying false. That's a little bit crazier. And then you're saying position 0. So like whatever is bound at the buffer, I want you to start at position 0. And then you're doing GL uniform. So now you're giving that program that you created earlier, you're giving it values. So you're saying uniform matrix, because we're sending in the projection and model view matrix uniforms. And this shader projection matrix uniform, again, is like a location inside of GL. So again, okay, so don't be worried about the fact that you don't understand like how to get this, you know, this location. Just understand that like what you're doing is basically just rinsing and repeating. Like send another one. Make sure that you had that original, you know, make sure that you got that location so that you can put that into this one, and model view matrix uniform. And you know the same thing is happens here, false and model view instead of matrix or projection. Oh, I'm sorry. Well, I'll stop in just 1 second. And then finally, at the very, very, very end of this, GL draw arrays. And remember, we have that object, the square, and it has a primitive type. So that was GL triangle strip. 0 is where you start, and obj dot number of verts, which is 4, draw. And that's basically it. So, I mean, it's a lot, but, you know.
I think, so, tell me if I'm wrong here, but
yeah.
So a lot of these GL calls, all the GL calls actually after shader program are just sending in the variables that will become in the shader program's model matrix.
Exactly. 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 So again, there are, like I wrote on the board, a million fucking GL calls, right? There are just a billion different things that you can do. But whenever you get down to it, you're literally saying, hey, I want to clear the color. I want it to be black. I want to clear it right now. I want to bind that buffer that I made. I want to use that program. You're just literally telling it, Now I want to send you some data. I want to send you this specific data. I want to send you this specific data. Now draw all of the stuff that I've set up. So it is basically just a really intense state machine.
Right.
Does that make sense? No? It's like literally, here's a good way of thinking about it. Whenever you go to the library, right? The library has 100 million books. Like, let's say Boast, right? The library has 100 million books. And you're like, I want to put my book inside of this library. But how would I ever be able to find it again? Well, there's a librarian. So you tell the librarian, hey, this is my book. And the librarian marks it down and it says, cool, this is my book. All right, awesome. And then they put it somewhere. You never get to see where they put it. But next time you go to the library, you just ask for your book, and the librarian's like, oh, cool, yeah. Do you want to do anything? Do you want someone to read your book? Okay, cool. I'll have someone read your book. So you can think about like GL is like GL is the librarian. GL is the librarian. And the librarian is dumb as shit. The librarian literally has to be told every single thing. What is the first letter of your book? What is the second letter of your book? What is the third letter of your book?
I guess what's confusing me is like, when did we ever make a color buffer?
So whenever you see exactly. Yeah, no, okay. So don't worry. So whenever you see all caps separated by underscores, they're basically like GL names that actually do some specific thing to GL that only GL knows about. So like
covering things up for you.
Yeah, like so you could think of like Dewey Decimal System in the analogy to like there's like this crazy Dewey Decimal System in the back room of the library where there's a million things, and if you just say color buffer bit to the librarian, even though you don't necessarily right this very second understand what that's doing, GL definitely does, and they will clear the right thing.
So she's not a stupid.
Yeah. But so, does that make sense?
I like that GL is now.
Yeah, and so the same thing with the array buffer. The same thing with the array buffer. Array buffer, it's just a bunch of numbers that people have made an interface to. Literally, that is all GL is. And then it gets, and don't fret because, Three.js is about 1 billion times. So everything that we just did, and we're not even done, but we're gonna stop here. Everything that we just did will be constructed in about, like I said, 10 to 13 lines of code. And it's much more like create vertices, like pass vertices, draw vertices. That's it.
Wait, as in this what we just said in this whole context, and the drawing function, everything, the shader programs. I mean, obviously we'll have to write the shader programs, but is this wrapped up in Three.js?
Yeah, it's all wrapped up.
Oh, okay, so we're not going to do this.
The
Yeah.
library contains all this shit.
Yeah,
Exactly.
But it's really important to know what it is.
It
It's
is.
to know what.
And just to know like the background of what's going on so that you can like kind of understand how to manipulate it better. And you don't need to memorize this stuff right now. You will get it along the way.
And here, Betsy, I want to point something out to you, and you too, TK, that's maybe confusing. I just realized. So this here, we made this model view matrix.
Yeah.
In order to get that into this variable, which is what we want, because we want to include that in the position.
Mm-hmm.
So we made that. The way to get it into that shader program is we have to call it here, and we send it in there. So GL uniform matrix for FV. This is how we get that function, that GL function is how we get it from being just a regular matrix to being inside the shaders, so we can use it as part of our vertex position.
Basically, it's shipping that. It's taking that on the ship.
And it's the same for the next one, the projection matrix, and then
the same with the
vertex attribute here, this vertex. So these three things are exactly putting the information we wrote in these three arrays into these three variables that we can then use.
The way that you can think about it is, even though this is not exactly what's going on, you could think about it like this.
Yeah.
Does that make sense? So you're like just returning the actual, vertex.
That makes sense.
Does that make sense?
Yeah.
Cool. No problem. And again, we're not going to need to know all of this stuff. Just really, really good to understand that like what's going on behind the scenes is actually very complicated. But when you get down to it, after using it for a little bit, like, oh, well, I created a buffer. Well, I need to bind that buffer. Well, if it's bound, then I need to bind my shader that's going to use, that's going to calculate stuff. And then I need to send that shader my stuff, all of my data, and then I need a draw. And that's basically it. And that's the thing. It looks really crazy, and it looks scary as shit. And believe me, I've been scared to death of it for a long time. But now I'm like, this is easy. I mean, it's not easy. Don't get me wrong. It's not easy, but it's much less scary than it originally was. And this is what you basically created. So you can see that this, like, yeah. So
Why
you
don't we
can
just
see
go
that
to
it,
processing and like square?
yeah, exactly. But that's what we're going to do in Three.js.
Yeah.
Okay, so why doesn't it appear?
Because you haven't done the shader stuff. So that's the next thing. The book isn't going to go over every single part of the code, nor am I going to go over, because I think we've gone far enough for tonight, and we can go over stuff tomorrow. But that's why this site comes in handy. Enter 3dprog herokuapp.com. So whenever I go to the About page, it has this site, and I'll try to make that more visible. But right after the WebGL up and running book PDF, it has this site. So I can go to chapter 1 and I can see, oh, so he made a function init WebGL, and he did it like that. And they made it init viewport, and they made var projection matrix and model matrix outside of the function, and then whenever they initialize that, then it takes the variables that are inside of that function, or that are outside of that function, and gives them values inside of that function. And then they have the create square, and then here's the shader program. So this is like what we didn't go over, and this is literally rinse and repeat, but I would just say like write it down, because seeing GL calls will slowly become like very easy to understand. Oh, shader source, well then I'm giving it a string. Oh, compile shader, cool, I'm telling GL to compile that source. Get shader parameter, okay, compile status. Oh, so it's checking to see whether or not it compiled correctly. Just go through it and make sure that you can kind of understand. Oh, it's returning the shader, so clearly somewhere down here it's going to do something. And then they create the shader program stuff, and then attach shader, which is kind of like bind vertex buffer, and attach shader and link program, so that's basically creating one program out of that, and yada yada on and on and on. And then at the end it has this stuff, and then this onload function is basically where we do everything. So you can see like function onload, create the canvas, document.getElementById, WebGL canvas, or whatever ID you've named your canvas, and then var gl equals yada yada yada, on and on and on.
So now actually use the function with this one. And that's where it does.
Yeah, exactly. So now we're getting this square thing, and then we're saying draw GL square, and then it does it. Does that make sense?
The only thing we did was create the shader.
Yeah, basically. And again, those are going to be very, very rinse and repeat, but I would suggest going over them just so that you like understand, like, we are just calling GL. Never be afraid of GL. It is your friend. Just has very... What?
If I'm never going to have to write this, why don't I just copy
Because
It's good.
it's good to know, and you will at some point as you start to make more and more complex stuff. It'll become easier for you to call GL than it will be to call Three.js. But again, just write down the code, because any code writing is good code writing. Cool?
Yep.
Everybody understand? Hopefully you at home understand as well, and we will, yeah, we're done.